Glacier response to climatic forcing. Variations in climate are commonly linked to glacier advances and retreats. Despite some transient advances, glaciers in the Cordillera Blanca have shown continued recession since the mid-19th century. Every glacier has an accumulation zone, where it gains mass, predominantly from snow, and an ablation zone where it loses mass to evaporation, sublimation and melting. The annual equilibrium line altitude, ELA, delimits these two zones, above which accumulation exceeds ablation. ELAs can be understood through changes in temperature and precipitation. Increased temperature and decreased precipitation causes the ELA to ascend, and decreased temperature and increased precipitation causes the ELA to descend. Persistent rising of the ELA of glaciers in the tropical Andes has been documented in recent decades, by as much as 300 meters in some cases. Glaciers of the Cordillera Blanca lost 22.4% of their area from 1970 to 2003. Due to higher temperature increases at lower elevations, much of this loss has been in small, low-lying glaciers. In addition to implications of precipitation and temperature, atmospheric humidity also influences melting and sublimation. A decrease in atmospheric humidity is thought to be one of the major reasons for glacier retreat throughout the tropics at the end of the Little Ice Age. Studies suggest that in the 1930s and 1940s, temperature accounted for one-third of glacier retreat in the Cordillera Blanca, while factors promoting decreased humidity accounted for the remainder. Alternately, accelerated recession since the 1980s is attributed to increased air temperature and increased air humidity. Observations show that humidity increases during the wet season are particularly responsible for elevated melt rates. In general, however, quality atmospheric humidity records are absent for the Peruvian Andes, and most studies suggest that temperature has greater relevance to glacier mass balance. Glacier mass balance is clearly sensitive to changes in both temperature and moisture, and these are also tied to climatic anomalies such as the El Niño Southern Oscillation, ENSO. ENSO is identified as the largest influence on interannual variability of weather patterns and climate fluctuations on the global climate regime. As a result of ENSO on interannual climate variability in the Andes, mass balance is greatly influenced by Pacific sea surface temperature, SST, anomalies and their impact on precipitation. Due to warmer SSTs in the Pacific, the El Niño period is typically warmer as well as drier. ENSO events have been linked to significant negatives in mass balance, which is attributed to low precipitation, low albedo, and as a result, increased radiation exposure. La Niña periods are characterized by cold temperatures and more abundant snowfall, during which glaciers usually experience balanced or positive mass balances. Pacific SST anomalies in the tropics induce large-scale forcing on interannual time scales, resulting in negative mass balance during El Niño years and above average results during La Niña years. Changes in the upper tropospheric flow aloft associated with ENSO conditions determine snowfall magnitude during the wet season, thus, impacting mass balance. This teleconnection mechanism is spatially unstable and oscillates latitudinally along the subtropical Andes and affects the Cordillera Blanca in most, but not all years. Therefore, the connection between ENSO and glacier mass balance in the Cordillera Blanca features inconsistencies which have occurred more frequently since the 1970s, when El Niño and La Niña events featured above average mass balances and negative mass balances, illustrating that glaciers in the region are altered through the ENSO events. In addition, climate model research regarding the impacts on climate change on ENSO occurrences suggest climate change will promote an increased frequency of ENSO events along with increased intensity, which is expected to be a further detriment to glacier mass balance and seasonal water availability in the future.